Good morning, happy geometry students. So I left you last week with a problem that looked an awful lot like this. And I'd like you to open today by trying to do this one. And I'm going to put down the pause, think, and try sign. Don't you dare hit play until you've done the problem. Well, alrighty then. So since you think you're done, let's walk through this guy. If I want to know what this side here is, and I don't have a right triangle to begin with, how am I going to deal with this problem? Well, I need to create a right triangle. So we drop a perp, you drop a perp, bam! And then I can find this height right here. For right now, let's call that y. And in this right triangle here, y is what I'm looking for. That's the opposite side. 11 is the hypotenuse, so I'm going to use sine. So sine 29 degrees is equal to y over 11. Solve that for y by multiplying both sides by 11. So y is equal to 11 sine 29. Okay, so that's that value right there. Now I can look at this right triangle. I've got an angle, an opposite side. I'm looking for the hypotenuse. So again, I'm going to use sine 48 degrees is equal to the opposite side, 11 sine 29 over x. Got to solve there for x. So I multiply both sides by the x, divide both sides by sine 48. And then I go to my calculator. All right, so that is so last Friday, and most of you got that answer, that kind of a problem type, correct? So I'm pretty happy going on, although I'll bet you you're just dying to confirm that you've got a value. So 11 times sine 29 divided by sine 48, and doohickey there, I'm in degrees, equals, I think my answer is 7.176. All right, if you did not get that, go back and look again. All right, so that was so last week. Of course, we're going to progress with this and look for a new pattern. So let's start here by saying, hey, yo, what if I didn't have a single number on my problem? What if I had nothing? All right, so let's just pretend here that I'm going to call this angle A and this angle B. And let's say that I know those two values, but right now I'm just saying they're variable. And let's say that let's say I know this side here, but I'm not going to give you a number. I'm just going to call that length B because it's across from angle B. Looky there. Okay. And this side here is what I'm looking for. In the end, I can use the variable a for that, but this is the thing that I'm looking for. Okay, so let's pretend that I wanted to do this problem here, but I don't have a single number in sight. Okay, I would do the problem exactly the same way that I just did. I'd be like, hey, yo, I don't have any right triangles, so what am I going to do? I'm going to drop a perp, drop a perp, bam! And then I could say, hey, I could find this length right here. I could find the height because I've got this angle. I don't know what it is, but I know I've got it. So I could say that sine of angle A is equal to the opposite side divided by the hypotenuse. And then I could solve that for x. So x is equal to b sine A. And then I could be like, hey, I could plug that value in right there, whatever it is. I could come to this right triangle and I could say, hey, I've got an opposite. I'm looking for the hypotenuse. So I could say sine of angle B is equal to the opposite side, B sine A, divided by the hypotenuse. And keep in mind, that is the thing I am looking for. Okay? So if I wanted to solve for that, I could say, hey, multiply that to the other side. A sine B is equal to B sine A. And you know what? That looks like a really super intriguing equation right there. A sine B is equal to B sine A. You know, since we don't have any numbers, we don't really know where a good stopping point is. Let me just take this here and move it off to the side. And I'm going to look at just that equation that we just wrote. A sine angle B, where A is the side length that's across from angle A. B is an angle, is equal to the side length of B, which is across from angle B, sine angle A. And that was like for some picture that looked like angle A, side A, angle B, side B, where these guys here are the sides opposite. Okay, so that's kind of a pretty equation, but you know what? I'm tidy. I'm a tidy person, and so I want to get all of my A's on one side and all of my B's on the other. Okay, so I also want to get all my A's on the left and all of my B's on the right because I'm super duper tidy. So the first thing I'm going to do is I'm going to use my reflexive property and say B sine A is equal to A sine B. All I did was flip-flop my equation. And now I'm going to get all of my A's over to here. So I'm going to divide this A, divide both sides by A. These would cancel. Then I'm going to divide both sides by B. These would cancel. And what I'm left with is this equation here, which is an equation with 4 variables. And as long as you know 3 of them, you can find the 4th. In this case, we knew angle A, we knew angle B, and we knew one of the sides, and we were looking for the other side. All right, so having said that, sine of A divided by side A is equal to the sine of angle B divided by side B. Here's what I'd like you to do. Try this problem right here. See if you can figure out how to solve for y. And when you do, hit me up with a text on Remind that has the value of y to the nearest 10th. To the nearest 10th. After that, there's going to be some problems up on Canvas for you to do, but for right now, just try to solve for that one problem, that one value, y to the nearest 10th. Hey, good luck. And you know what? I'm going to end with a joke today. I was not sleeping well last night. I was up all night thinking about where the sun was, and then